Hello there, and welcome to another video. Today, I'm going to start by showing you the most disgusting thing there is in Java, and that is int division. So the way to do int division is just by typing one int, followed by a slash, followed, typo, by another int. And then if you type that, the first int will be divided by the second one. So the disgusting thing about int division is that when we divide two ints that do not divide evenly, so that means that the answer has to be a fraction or a decimal, Java will give us an incorrect int value as an answer instead of a decimal place or a fraction. So if I run all this code I've written here, ignore everything from like here down. I've written like tons of code that I'm going to be running repeatedly today, but just look at whatever anytime I run the code, just look at whatever we're dealing with currently. So that's this stuff here, this. So it prints out 100 divided by 8 equals, and then whatever it evaluates 100 divided by 8 to be. Again, this is just a string, don't be confused by it. And it evaluates this to be equal to 12. And just to remind you guys and myself, 12 is not the correct answer to 100 divided by 8. 12.5 or 12.5 is. So the way the computer decides which integer to pick as the result of int division, when you should really get a fraction value, is it always picks the int right below the actual answer. It will never round and pick the int above the actual answer. So if you have it perform some int division that should result in the answer 9.9999999, no matter how many nines there are, the computer will evaluate it as 9, never as 10. Disgusting, I know. So the way to fix this problem is by having the computer consider the numbers not as ints when it divides them, but as another data or variable type called doubles. To have a number considered a double, simply add a decimal point, which is on the same key as the period. Well, it's not on the same key as the period. It's the same thing as the period. You create one by typing the same key, it looks the same. It means a different thing depending on if it's a number, depending on if it's placed in a number or a sentence. Like this here, that's a decimal. This, oh actually that's right after a number, so it looks like a decimal as well here. That's a period. It's the same symbol though, it just means different things. Anyway, so we add that decimal point to the number to make it into a double and not an int. So this here, 10.0, instead of 10, this here is an int, this here is a double. This is just a period at the end of a sentence. You can ignore it. So to declare a variable intended specifically to hold a double, do it the exact same way you would declare an int, but put the word double where you would have put the word int, like this. So double, then the name of the variable, equals, assign it a value, semicolon. So some additional things you're going to need to know about ints, doubles, and mathematical operations using ints and doubles. First thing, as a general rule, if you do a mathematical operation where sorry, I know I'm not reading from my script anymore, this is something I forgot to put in. Firstly, if you do a mathematical operation between an int and a double, so like if you add an int to a double or multiply an int with a double, subtract, divide, etc., you'll just get an answer that's a double, and the int is like upgraded to a double. Anyway, I'll get into that in more detail later, but just keep it in mind for now. So first, well, I guess not first now. Second, doubles are very accurate to many decimal places when determined mathematically, but actually become wildly inaccurate after about 10 decimal places or so. So that means that if you give a double a value that you determine with math, like this here, it's not actually going to have the correct value. Like it's going to have a value very close to the correct value, but almost never actually going to be correct, which is super weird. But if you look at this here, this stuff that printed out as a result of me running this code, it says that 10.6 times 6 is equal to 63.5999 repeating with a 4 at the end. And that's just not the case. The correct answer is 63.6, which is very close to 63.5999, but it's not 63.5999. So the reason that I showed you this is to hint that you should not compare doubles using equals equals, because equals equals tests if the values on both sides of it have the exact same value. You can compare them using equals equals though. Like the computer will let you do it and it won't cause a crash. You just shouldn't, because it will not work all the time. And what I mean by not work all the time is if you want to multiply, like say you have some double and then you want to multiply it by some number entered by the user and then test if it has some value, let's say 20.2. If you compared them using 20.2 equals the double times whatever the user entered, even if the correct answer to that double times whatever the user entered is 20.2, the computer won't evaluate it completely correctly, so the comparison won't actually work, and it will evaluate to false, even though it really should evaluate to true. So what I'm getting to is you should, instead of comparing doubles using equals equals, check if they're approximately equal using greater than and less than, like so. So if the number that's going to result from the mathematical expression is greater than some number slightly lower than the one that we're actually testing for, because we're testing for 63.6, and that same value, this same value, resulting from this mathematical expression here, h times 6, is also less than some number that is slightly larger than the one we're testing for, because we're testing for 63.6, and here we're using 63.6000000 repeating 1. So this is testing if it's approximately equal, okay? If h times 6 is approximately equal to 63.6. And if it does turn out to be approximately equal, I have set the computer up to print out the computer thinks they're approximately equal, just so you can see that the test worked. And if it doesn't think they're approximately equal, it will print out the computer thinks they are not approximately equal. And then after that, I have a testing if they're exactly equal. And if they are exactly equal, the computer will print out the computer thinks they are equal. And if this doesn't evaluate to true, then it will print out the computer thinks they are not equal. So let's have a look at what it printed out. So it says the computer thinks they are approximately equal, but that they are not equal, which is the case that this number here isn't exactly equal to 63.6, but that's only because it wasn't evaluated quite correctly. The actual value you should get is exactly equal. So that's the reason that you don't test if doubles are exactly equal. The interesting thing is that this number here is not far from the correct answer. And neither is this one, these two that I'm using as the upper and lower ranges. You'd think I'd have to go up by at least one whole number, or at least 0.5 or something, but no, I only went up by 0.00, up to find the max and down to find the min by 0.00000 many zeros, 1. So it is actually still really precise, it's just not quite perfect. But if you need to use comparisons of numbers like after the decimal point, then this is more precise than with ints, because if you just had int, these as int values, this one here would just be 63, and then this one would just be 63 as well. So it would only prove true if it was exactly 0.6 off. Okay, now note that, actually I think I've just explained this paragraph here. So this is the first thing I explained, but I'm just going to go over it in more detail now, go over it maybe more clearly. Note that while doing math with both ints and doubles can be confusing, the only thing that will actually lead to a crash that you need to worry about is if you try to give an integer variable a double value. Trying to give an integer value to a double variable will cause no problem at all. So this here, random double name, this is just the name I picked, equals 4, which is an int, not a double, because I didn't say 4.0. This will not cause a crash. This variable will know that it needs to upgrade this to a double to 4.0. Whereas this here, int random int name equals 4.0, I won't run that because that would cause a crash. Even though 4.0 could be changed to an int without changing its value, it will still cause a crash. So it doesn't even have to be like 4.1. 4.0 will indeed cause a crash, I assure you. So the next thing I'm going to show you is a new concept called casting. Casting is something you can do to temporarily convert a value of one data type to an equivalent value of another data type. So there are many kinds of data types that can be converted to many other kinds of data types. But the only two kinds that you have seen so far where it actually makes sense to convert them is to convert a double to an int when you are determining the value an int variable will be given based on math using doubles. So a case where we might want to do this is if we were trying to give the position variables of a game character, which have to be represented by ints because we can't draw the character between pixels. So we're giving these position variables values that we determine based on math with doubles. For instance, if we were trying to increment the position of a character in a game based on some amount of force that the player chooses to apply to this character or object that's in the game that they're pushing, we probably wouldn't just increment it directly by that. We'd want to do some math with that number representing the amount of force applied to find what distance the object would move. So let's say distance pushed, so in this case, sorry, I have distance pushed equals sc.next double times 3.7. This is just an arbitrary thing I picked, times 3.7. It could be anything else, but it's just to show that it's math with doubles. And then I increment the x position by the distance that the object or character was pushed. So if I were to do this right here, this would cause a crash if I didn't cast, because I am incrementing the value of an int by the value of a double. Sorry, I don't know if you've seen this plus equals before. That means that the value on the left equals itself plus the value on the right. Sorry, the value on the right. So because I've done math, I've assigned an integer variable, the value of an int, which was its previous value, plus a double, I'm assigning it a double value, so that will cause a crash. But if on this line I temporarily casted the value of this to an int, it would be less precise. This value wouldn't be perfectly precise, it wouldn't be super accurate, but it would not cause a crash. So if we use, first of all, note that we use sc.nextDouble when we're trying to get a double value from the user, instead of sc.nextInt when we're trying to get an int value. And we still need to call the sc.nextLine method each time after we call sc.nextDouble or sc.nextInt in order to stop issues from occurring later. Also note that I'm not going to run this code here because it would cause a crash. I just explained why. So the way to fix this would be to add right here in brackets, would be to, like I said, cast this to an int. Now the way to cast is put brackets around, this is the statements that's going to give you the value that you're trying to cast, which in this case is just this. And then beside that now bracketed block of stuff, put another set of brackets, and in the new set of brackets, just type the name of the type you're casting to, like so. X position plus equals distance pushed in brackets casted to int. That's what this line means. Compare this line here to this line here. And then you'll see what value it gives us. So if we just look, hang on, let's run this code again. So the computer tells me to enter the amount of force applied. So I'm going to say 5.4. I go enter. And then it prints out a bunch of other stuff from demonstrations later on, but I'm just going to scroll up to the one we're dealing with right now. Right here. So I enter the amount of force applied, and then it tells me the new x position. And, oh, ignore those next two things as well. Okay, whatever. Just ignore these two things here for now. But basically, it prints out the new value of the x position variable, which is 19. And if we actually do the math on a calculator, the value of 5.4 times 3.7 is 19.98, I believe, which is much closer to 20 than it is to 19. But at the same time, it is close-ish to 19. And if we had just used ints instead of doubles, and as a result just been using 3 and 5, then we would have gotten 15 as an answer instead of 19. So again, the doubles aren't perfect, but they get us much closer to an exact value than ints would. And generally, this being off by 1 will be close enough for our purposes. Also note that when I cast this to an int up here, this does not stay an int after this line. If I were to print out the value of distance pushed after this line here, it would still print out like roughly 19.98. It wouldn't print out 19. Because this just temporarily casts the value that this returns to another type. It doesn't actually change the type of the variable. So, moving on. First, I'm actually just going to comment this out so it doesn't interfere with later demonstrations. Okay. Now that we've seen how to cast and how to avoid crashes, I'm just going to quickly show you how to avoid any remaining imprecision that could be caused by all the numbers after the decimal point of the quotient of two ints just disappearing. The first thing you can do, if the ints are entered as constants, meaning not variables, like just 10 over 3 rather than like x over y. So the first thing you can do if that's the case is to simply make one of those ints into a double by adding a decimal point to it. That's why you don't usually need to cast ints to doubles also, because if you want to have an int as a double, just type 0.0 or just add it to another double. So anyway, you can just make one of them into a double by adding a decimal point. And if an int is divided by a double, or doubles divided by an int, then the answer will be the same double that you would have gotten by doing the same operation, where both the double and the int were in double form. So for example, 5 divided by 4.0 will get us roughly 1.25. 5.0 divided by 4.0 will also get us roughly 1.25, and it will be the exact same value that 5 over 4.0 would get us. This and this will evaluate exactly the same. So if I said like this equals that, it would print out true. Okay? It wouldn't necessarily print out true if I said this equals 1.25, but it would be true if I said this equals this, or this approximately equals 1.25, or this approximately equals 1.25. And then this here, 5.0 over 4, will be the exact same as this and as this. While 5 over 4, neither of them being decimals, will just return 1. So if you cast an int to a double before dividing, like we just did up here, because like I said, this is actually casting 4 to a double. So if you cast an int to a double before dividing, it will also work. So for example, casted to a double 5, the reason you might need to use this type of cast instead of this type of cast is that if this is a variable, you can't say like x.0, so you'd have to say double x, if this were an x and not a 5. So this here will return roughly 1.25, okay? And if you cast after dividing, you will lose your decimal places. So 5 over 4 casted to a double will return 1.0 exactly, not 1.25. Not roughly 1.25, 1.0 exactly. So now I challenge you to write a method, which you should remember what methods are from the last video. I'm just going to scroll up and show you like a blank method probably at the end of this paragraph here so you can remember what they look like. But anyway, I challenge you to write a method called round, which is passed a double parameter and returns an int, okay? And the int it returns is the nearest int above the double if the first number after the decimal place is 5 or higher, and the nearest int below the double if the first number after the decimal place is 4 or lower. So for example, round 7.5 would return 8. Round 3.2 would return 3 because 5 is greater than, so 5 is equal to 5 or greater than 5. So we round up, not down. So we round up to 8, not down to 7. And 2 is less than or equal to 4. So we round down to 3 instead of up to 4. So now I'm going to give you a second to pause the video, and then I'll go up to the top of the page to show you my solution. Although before I do that, actually, I'm just going to show you the header for another blank method. Give me a second. I go up. Yeah, that'll work. So just look at this header here. Public static void print array. Okay, so now's your chance to pause the video and try to do this with the thing I just challenged you to do before I show you my solution. Okay, now I'm going to go up and show you my solution. So here it is. Public, again, not relevant yet, but will be relevant very soon. We're getting close to that video now. Static, just something that needs to be there. And we're also getting close to the point where I explain it, but I haven't really explained why it's necessary yet. Int, which is the return type. Round, which is the name. It doesn't have to be called round, but I think I did tell you to call it round. But if you call it something else, it doesn't matter. And then double Q, because it needs to be passed a double parameter. This is just a temporary name. If all this stuff I'm saying to you is sounding like gibberish, you should probably go look at the last video, or at least the part on methods. Probably like skip through most of it to get to the part on methods. But anyway, so we have a temporary double value called Q. And what I do is I assign Q the value of Q plus 0.5. And then I return Q casted to an int. So what that does is, if Q has the number right after the decimal place in the double Q has a value of 5 or higher, then if we add 0.5 to Q, then Q will be, like, it will have a value one whole number higher than what it had before. So casting it to an int will result in a number higher than just casting the original Q to an int would. So for instance, let's say Q has the value 8.6, okay? So if we were to cast 8.6 to an int, we would get 8, okay? But if we add 0.5 to 8.6, then we get 9.1. And if we cast 9.1 to an int, we get 9. So that rounded up. And if our value were instead 7.4, if we were to cast this to an int, we would get 7. If we were to add 0.5 to it, we would get 7.9. And if we cast 7.9 to an int, we still get 7. So it rounds down. Okay? So that's how this method works. Now I'm going to scroll back down to where I was and continue. So where was I? I think I was, no, not there. Here. Oh yeah, okay, so here I just tested my method. So I passed it 5.5 and it returned 6. And I passed it 5.4, it returned 5. So that means it probably works. So moving on. Now I'm going to show you a new method, which is, and a method as in an actual Java method, not as in a a system, like a way of doing something. So I'm going to show you a method which is super handy for games and some other things. This method uses the computer's built-in random number generator. It is called math capital M dot random lowercase r, open bracket, close bracket. So it takes no parameters and it returns a random double value with a minimum possible value of 0 and a maximum possible value of anything and everything less than, but not including 1.0. So to clarify, it can return 0.0, exact, like absolutely 0, and it can also return 0.99999 repeating infinitely, but it can never return 1.0. It cannot return 1. So, for example, it could return this number here. And it has an equal chance of returning every possible value between 0 and 0.99999 repeating to as many decimal places as doubles are capable of. So now I challenge you to write a method called random in range that takes in two integer parameters and returns a random integer with any value between those two integer parameters it took in, including both the parameters themselves. Including both the parameters themselves. So if you passed in like 3 and 7, it could return 3, it could also return 7, and it could return 4 and 5 and 6. It would only return one of those any given time that you ran it, but it could return any of those. So after you're done writing this method, test it the way I did down here. All this code here, okay? To see if it works. Or if you don't understand this here, you can test it another way or just not bother testing it. I don't really care that much. So anyway, so test it or don't. And then, but the reason you want to test it is to ensure that it actually returns each integer that it can return with equal frequency. So this is actually a very difficult challenge for new programmers, so don't worry if you can't get it. In fact, I actually had to, I did manage to get it, but I wasn't sure if it was quite working, so I had to look it up online, as you can see here in this tab, just to make sure that I did do it correctly. So now I encourage you to pause the video and go do this. So I'll wait for a sec, and then I'll go show you my solution. Okay, now I'm going to go show you my solution. So I go up. My solution is here. So public static, you know the drill, int, return type, random in range, name, one int parameter it takes in called min, another one it takes in called max. Then I set it to return min plus, I'll get to the int cast in a second, math.random times 1 plus max minus min casted to an int. Now, if you're wondering why that works, here's my explanation. So, the lowest value that we can get for, math.random is 0, okay? So 0 times 1 plus max minus min evaluates to 0. So min plus 0, because if you cast 0 to an int, you still have 0. So min plus 0 returns us min. So we know it can return the minimum value, and we know it can't return anything lower, because if this returns its lowest possible value, it gives us min. Okay? Now, the maximum value this can get us is 0.99999 repeating. So that, 0.99999, times 1 plus max minus min returns just under 1 plus max minus min. Okay, because if we did 1 times 1 plus max minus min, that would just be 1 plus max minus min. So this here, in the case where when this returns the highest possible value it can return, then all of this evaluates to just over max minus min. And then if we cast just over max minus min to an int, all of this will return us max minus min. And if we add min to that, max minus min plus min, that's max. So the max value we can return is max, and we know we can't hit anything higher because that's the max value. So that's how we know that this can hit all the numbers in, we know that this can hit all of the numbers it's supposed to be able to hit, and we know it can't hit any other numbers. So I just tested it to make sure it returns numbers in the right range with my test down here. Here, I'll just really quickly explain to you what this does, this test here. If you don't understand it though, that's all right. If you think you can, it probably would be good practice to walk yourself through this and figure out how it works, but if you can't, that's also okay. So what I did is I give max a value, I gave min a value. This isn't how you assign the values of the variables max and min that the method call actually uses. I just called them max and min so I could remember what they were supposed to be. Originally, I just put in the number 54 everywhere, but now I've just put in the number max. And same thing for min. So first, I declare an int array of length max plus 1, okay? Then I use this for, have I shown you for loops yet? Oh, I don't know that I've shown you for loops yet, come to think of it. I suspect I haven't. Okay, I'm just going to walk you through what they do. They're exactly the same as while loops, except the variable that counts how many times you've gone through is declared in this set of brackets before the first semicolon, and it's given its initial value. And then the parameter that would go in the brackets for a while loop goes after the first semicolon before the second semicolon, and that tells us what we're checking to make sure is true to run the loop. Like if this here proves false, then we stop running the loop. And then what we do to the counter variable at the end of the for loop goes in the final space after the second semicolon before the final close bracket with no semicolon after it, and that's incrementing I by 1. I don't know if I told you what plus plus means, but it just means this variable here now has the value of itself plus 1. So basically this just gives, sorry, my voice cracked there. This just gives the value 0 to every place in the int array R, okay? So because if we try to add stuff to the contents of an index before we assign a value to that index, we get a crash. So we have to actually assign it a value. So we assign all the spaces in the int array R 0. Then 1 million times basically is what this means, while I is less than a million. At a random index of array R, increment its value by 1. So because we're doing this, that's actually determining what this array really means. I didn't tell you why I was declaring this array, but now I will. The reason I declared it and what it's doing is each space in that array is holding the number of times that the index of that space has been returned by this method so far. Okay, so we're going to call this method 1,000 times, and then we're going to have a list printout. That's what this does. This just like prints out a list. We're going to have a list printout of all of the indexes of the array with their content. So, but really what that is all of the numbers that the method returned, followed by the number of times that number was returned. So the number 7 was returned this many times, the number 8 was returned this many times, etc. Okay, and then the last thing I do is sorry, I didn't tell you what. Okay, so that's what this does. This just fills the array. So now we have all that data of how many times each number was returned stored in this array. And then here, what I do is first I print everything out, but I also set this value sum to the value of all of the contents of all the spaces combined. And then I print out average is equal to sum over the number of spaces. So that basically that's the average value that each, like the number of times that each number should be printed out roughly. So that's just to confirm that everything was close to that number. So if we go down here, the average was 21,276, and it looks like everything was printed out roughly 21,276 times. Like these are all pretty close. Like we're not seeing anything drastically off, which suggests that this random method does work as intended. But if you didn't understand this test and how it was working, that's okay. Like if you don't know how averages work, that's not something we really need. It's just some test I did that's handy. Okay, now we're going to move on to the next topic. So the next topic that I'm going to be talking about is called array lists. So an array list is like an array, except there's different things it can hold. Like arrays can hold ints or doubles or booleans, and array lists can hold strings or arrays or colors. So that's the first difference between them, but that's not the main difference. The main difference is that array lists can have their length changed. Like you can add stuff to an array list. You can make it longer and you can remove things and make it shorter. And that's going to be very, very handy for making games. It's actually going to allow us to spawn in enemies. And like when they die, have them disappear. So the number of enemies can change. So the game can start out with like 2 enemies, say, and then like more spawn in over time. And like if you kill a bunch of them, they disappear and the number goes down. And then more spawn in, it goes up again. So first, I will show you how to declare an array list really quickly. So I'm just going to scroll up to the intro block of this file I'm working in where I declared an array list. So I'm going to go up. And here is the array list I declared. So I said static. Again, you could say public static or just static, not relevant, but you do need to say static. Then you type array list, capital A, capital L, open caret. This is being used as a type of bracket that you've never seen this used as a type of bracket yet, but this is a left side is less than right side sign. So open caret, int array, close caret, and it doesn't have to be int array. I picked int array because that's what I want my array list to store. You could put string or color in here, or double array, or Boolean array. Okay? So static array list, open caret, int array, close caret. The list, that's just the name I picked. You don't have to write the list. Okay? Then we want to assign it a value, which you don't absolutely have to do, but you probably should at the beginning, just to avoid some other issues, equals new array list, open caret, whatever it's holding again, close caret, open bracket, close bracket, semicolon. So that's a long thing to remember. If I were you, I would write this down somewhere or take a picture of this and like edit it so that there's a circle around this line so you can see what it does. Because this is a lot to remember. The number of times I've looked this up on the internet, it's got to be at least 50. I have it memorized now, but I should have just memorized it the first time. So anyway, now I'm going to scroll back down and we're going to start doing some things with array lists. Okay, so now I'm going to scroll down. So go back down. And we are where's the beginning of the here's the array list related, the beginning of the array list related stuff. So here I am declaring 2 int arrays, and then I have it print out adding the arrays just so we know what's happening, and then I call the method thelist.add, and then the name of one of the arrays. So this .add method here, this is not something that you have seen before, so don't panic or anything. So the way it works is you type the name of the array list, not array list. You type the name of the array list you want to add something to, .add x. Okay? Well, not always x. And then the name of the thing that you're adding to the array list. And, I know this is probably kind of self-explanatory, but you can only add things to an array list if those things that you're adding are the type of thing the array list is meant to hold. It can't hold multiple different types of things. And then here I just add another thing to the array list. Oh, and if you try to, oh, actually, this command isn't relevant to that, so I'll talk about that later. So then I type print list the list. So don't worry about this method here, this isn't a pre-existing Java method you need to learn. This is actually a method I wrote myself to print out the contents of an array list in a manner where it's clear what the contents are. I'm probably going to challenge you to write it at some point in this video, but feel free not to, and it's not something you need to learn. It's just something I have, because if you try to just print out the whole list, it just gives you like a stream of like gibberish characters that are not really all that related to the list, not to the human eye. It's like some weird code that I don't know how to read. So anyway, if we look at what happened, it printed out adding the arrays, and it prints out the list. So at the first index of the list, we have this array, which has 5 at its first index, 6 at its second. What array has 5 at its first index, 6 at its second? Oh, the array X here. And then at the second index of the array list, we have another array with 9 at its first index and 2 at its second, or 9 at its index 0, 2 at its index 1. Because remember, index 0 is the first index, which is super weird. But anyway, the next thing I'm going to show you is this method here, name of an array list, dot remove some value. I think it's pretty self-explanatory as well. It will just remove that thing if it's there. So we scroll down, and as you can see, I print out the list, and the array X is gone. Also note that it's shorter now, the list. Like, it doesn't have some like blank space. No, it just has this. Okay? Now the next thing I want to show you is, oh right, so I'm not showing you a new method here, but basically what I do is I add the array X to the array list twice. Okay? Then I print out the array, so the array list, sorry. So here it is. Then after that, I change the content of X. So X at 0, so the index 0 of array X now equals 74. Then I print out the list again. And as you can see, the contents of the list, or the array list, has changed. Actually, I'm just going to call it the list because that's its name, but know that when I talk about the list is an array list. Okay? So if we look at its contents, you see the stuff at the index 0 has not changed because that is not, like, the stuff at index 0 wasn't the int array X, but the stuff at index 1 and index 2 were both int array X, so they both changed to the new value of int array X. So for this reason, if you're going to be adding things to an array list where they're going to be dealt with inside the array list repeatedly, I recommend that you then never change the value of that thing that you added to the array list and work with it only from inside the array list. So don't change it by name. So if you wanted to change the contents just at the first index, you could say, oh, hang on, we haven't actually gotten there yet. Sorry, but just remember to not change the values in an array list by changing the item that is outside of the array list that you added to an array list. So once you add something into an array list, you shouldn't change it by name. You should change it by getting it from the array list, which I'll show you how to do in a second. So the next thing I'm going to show you how to do is not how to get it out of the array list. So that seems like a bit of poor planning on my part. So here what I do, I declare a new array, and then I give it these values just to make it really obvious which one it is. And then I call this method array list name, which is the list, dot set index, comma, item. So what this does is it takes the first, not the first index, sorry, index 1 of the array list that we put here, and it basically deletes it, but doesn't delete the index, just deletes the context, not the context, the contents, so that index is now empty, but still there. It doesn't like delete the index, it just deletes the contents. And then it fills that index again with the thing you put in afterwards. So now then it prints out setting the value of index 1 just so we can tell what's happening over here. And then we print the list again. So if I scroll down, it says setting the value of index 1, and as you can see, it has changed it. Oh, and this is what I was trying to tell you to do earlier, actually. This is the way that you should change the contents in an array list. Like, just change, so pick the index that you want to change the contents of, and then give that index a new value. Don't change the contents of the thing that you added to the array list outside. So once I've done this, I would never want to change the value of R. I might want to change the contents at the list at 1, but I should never change the value of R. That can cause confusion. So I should basically just forget that this exists once I've done this. So next, I create a new int array, and right, here's the new method I'm showing you. So it's array list name, which is again the list, because that's the array list we're dealing with here. Because you could be dealing with more than one array list. That's why you need to specify the name. Like if I had some array list called the list of enemies and another one called like the list of allies, because it could be like chess and you have actual pieces on your team that aren't just your character, I would need to specify which list I'm modifying. Because if I just said like array list.add, it wouldn't know which one to change. So I say the list.add index, comma, content. So I've already shown you an add method up here that takes just content, no index. This one here has the same name, .add, and it also adds something, but it does it in a slightly different way. So what this does is it makes the list one index longer, like one thing longer. I think you know what I mean. And index, whatever value you put here, now has the value of the new thing, and whatever was originally at this index and everything after it gets shifted down one space. So I'll show you what I mean by that. So I add something new at index 1, and then we print out the array. So initially it was thing A, thing B, thing C, okay? And now it is thing A, thing Z, thing B, thing C. Those are just names I made up for these. These two things, this here and this here, got shifted down because this took the place of this, but didn't erase it. It would erase this if it were the list.set 1, comma Z, but because it's the list.add, it instead shifts everything down. So keep that in mind. Now, the next method relating to array lists that I want to show you is the .size method. So list name .size, open bracket, close bracket. And what this does is it returns an integer value that is the number of things in the list. And that's super valuable for doing something to every index of the list. Because you can't just say for I equals 0, I is less than some huge number, do stuff with the list at index I. Because if you just do that, if you just do stuff with the list at index I, and I gets a value greater than the size of the list, it will draw from an index that doesn't exist, and you'll get a crash. But if you use I equals 0, I is less than the list.size, I++ in a for loop, then you will know that you won't go too high. You won't go out of bounds and get a crash. The next thing I want to show you is the list.get. What this does is it just gives us the... Actually, let me just show you this. So I tell you it prints out the size of the list. I scroll down. It says printing out the number of items in the list because I told it to. Like it doesn't... This method here does not print out this stuff. This stuff is printing out because of this line. This line. So you've seen how this method works. Now I move on. So this method here prints out whatever is at the index that you pass here, indicated by an int, the index that you indicate with this int that you pass here. That's what I'm trying to say. So this method is actually, I think it's unique. I don't think I've seen any other methods that do this, in that its return type actually changes based on what the array list is holding. Because if the array list is holding strings, this method will return a string. But if it's holding int arrays, it's going to return an int array, etc. So that's very special. Now, the other thing you can do is you can use the remove method, except by giving it an index instead of a thing to remove. So if you wanted to remove a specific item, then you can just pass it that item and it will remove that item. But there's sometimes that you wouldn't want to do that because maybe you don't know that that item is in the array, or maybe that item is in there multiple times and you want to remove, say, the second one rather than the first one. But if you call this remove method, it will always remove the first one. So if I have like an array of strings and the first string is A and the second one is B and the third is C and the fourth is B, and I want to remove the last B, if I say the list.remove B, it's going to remove the first B, like the one at index 1, the one at the second index, which is index 1, not the one at the fourth index, which is index 3. But if I do this, I can specify which index I want something removed from. And just to show you, it does work. So remember, the list had this stuff. I removed whatever was at index 2, so 0, 1, 2. This should be removed. We print it out again, and we have A, B, C, D, and now we have A, B, B, this is B. We don't have multiple B's. I just said it multiple times because I failed to highlight this. D. C has been removed. Okay. Oh, and this is a for loop, which I was planning to show you for the first time, so I guess I didn't show you for loops before today. All right, so there you go. I have shown you for loops earlier when I talked about how I tested my random method. All right, now I just have one last new thing to show you, and it is, you can think of it like a method, but it's not actually technically a method. It's weird because it behaves very much the way a method does. It's for an array of anything, like doesn't matter what type of array, just an array, not an array list, but an array. And it behaves the same way as the .size method for the array list, but you type it using the name of the array that you want to get the size of, .length, not size, but then there's no brackets after it. So that means it's really a variable, not a method, but you can think of it as a method. But it's technically a variable. So you should remember that it's technically a variable though, because just so you remember not to put brackets after it. But if that's really hurting your head, then you can just remember that it's a method that you don't put brackets after. So what it is name of array dot length. So just to show you that, I created a new array called array because I'm a pirate, and then I just made it long, gave it a bunch of random values, and then I printed out the length of the array x and the length of the array. So let's just run this again. I just added this stuff right now because I forgot it earlier. Oh, yeah, I guess I have to enter a number to get past all the junk from earlier. So I enter a number. And, oh, hang on. I see why it's not displaying these things. There's an error, and that error is that I misspelled the word length. I wrote length. Okay. Sorry, let's try that again. So I run the code again. There we go. So x length is 2 because there are 2 items in the array x. And our array length is 8, to make sure that's correct. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there you go. That's that method. That's all the stuff I'm going to show you, like the extra new contents that I'm going to be showing you today. Or extra new concepts, sorry. Now I encourage you to go write the print list method. It's for int array lists. It doesn't work for any other type. You'd have to define a second method if you wanted to be able to print out the contents of an array list of something other than int arrays. So yeah, go try to write the print list method that I wrote, and then I'll show you my solution to that. Okay, now I'm going to go show you the print list method. All right, hello there. Here I am up at my print list method, and I'm now going to walk you through how it works. So it's of type void, and it takes in an array list of int arrays called R. All right, and then I declare a new integer with a value 0, and then I have a loop containing with the parameter while I is less than the size of the array list. And then at the end of this loop, just ignore all of this stuff here for now. I'm going to get to it, but just for now, ignore it. So this thing here that I don't have highlighted, that increments the value of I by 1. So basically, the first time we run through this loop, I is going to have the value 0. So it's going to do all the highlighted stuff to index 0 of the array list R. And then the next time we loop through, I will have the value 1. So it's going to do all the highlighted stuff to the index 1 of array list R. And it's going to keep doing that until I has the value size minus 1, r.size minus 1, which is the index of the last item. Like, it will be the index of the last item, I assure you. So then it will do all this stuff to the last index, and then it's going to stop running through the loop. And this is a very important concept in programming, where we do something to the contents of every index of a list, regardless of how long that list is. And this concept is called looping through a list. So keep that in mind. So the first thing you see is the outermost thing and first thing you see is that I have set this code up to loop through the array list it takes in, okay? Then I declare another new integer called 0, or called z, with a value 0, and note that because it's inside this loop, this whole loop, because it's inside of this, after one run of the loop finishes, this variable will cease to exist. So when the loop starts again, I'll be declaring it again anew. Oh, when did I add this second bit in here? Probably just now. Anyway, I'm just going to delete it. And this won't be an issue that the computer sees the declaration for the int variable z multiple times, because it ceases to exist at the end of the loop. Okay, so next, after I declare this in the first loop, I print out an open square bracket. That's just my choice of bracket to make it clear that a new array is having its contents printed out here. Like the printout of the contents of a new array is beginning where this bracket is. And then I have this while z is less than r.getI.length. Oh, sorry, I did that again. Okay, so just ignore how complex this statement is for now, but just have a look at this loop here and this little statement here right at the end of this inner loop, and try to think of what the name of the concept that's probably taking place in this loop is. Okay, now I'm going to tell you. This loop here is looping through the int array found at index I of the array list. Okay, so now I'm going to explain to you what this statement does. So before I walk you through exactly what it's doing, take note that there's two periods in it, okay? As a general rule, multiple dots being found in one statement means that if you ignore the last dot some stuff, everything before that is all going to be returning one value, because the last dot method call, or think of this as a method call. I know that dot length isn't really a method, but think of it as one. This last method call here is being called on whatever's returned by everything to the left of the last period. So we could have something like 7 periods deep, and basically what we do is evaluate the first one thing dot some method, because that returns one thing, and then evaluate whatever calling the method after the next dot, which in this case is this one, would return when called on whatever all of this stuff returned. okay? And then if there was something else, like if this was array.getI.length dot, I don't know, some method, then we would figure out whatever all of this returns dot some method returns, okay? But for now, we just have three things on sides of the period. So let's start with what this returns. So we say array.getI. Well, that's going to return us the int array found at index I of the array list. So then we go the int array found at index I dot length. Well, that's going to give us the number of items found in the int array at index I, if that makes sense. So I'm using this whole statement here to get the number of items in the array found at index I of the array list. And the reason I need to do this is so that I can get the proper number to set as the maximum value for z, so that we can loop through the array found at index I of the array list without going outside of that array and picking an index too high, because that would cause a crash. Okay, so now that you understand what this statement does, this big wonky statement, and that this loop is looping through the individual array, we need to think about what we're trying to do with each individual array. Well, the answer to that is we're trying to print out the contents of each index of that array. So the other thing we would need to do, however, is put some kind of space or divider between those between the contents of each index, because if we don't, it will look like it's all one big number. Like, say we print out 32 and then we print out 21. If we don't put a space or a comma or something between it, that won't read out as 3221. It will read out as 3221, if that makes sense. So before we get to this statement here, which is just printing out the contents of the current index of the current array, I have this, which prints out a comma followed by a space if we are not currently printing out the zero with, no, not the zero with index 0 of the current array. And the reason I have this parameter here is because you don't want a comma before the first item. But you could put one there and it would still be legible. It would just look weird. So if we were to omit this here, like, oops, method would still work. It would just look really messy because there'd be a comma and a space before the first item. So that's what all that does. And then this here just prints out the contents of the current index of the current array. So here's how we do it. All this here, it might look like it's only two statements separated by one period, because there is just one period here. However, when we're dealing with arrays, we don't need to say like dot get something. This open square bracket followed by an int value followed by a closed square bracket is equivalent to dot get at index whatever this is for an array. Dot get at index something is how you get the contents of a certain index of an array list. Open square bracket int close square bracket is how you get the contents at this index of an array. So this really is a compound statement again. So let's read it from left to right. First we evaluate this. So the array list, which we're calling R because that's the name of the temporary variable, dot get I. So now this generates the current int array. And then we get the current index, the contents of the current index of the current int array. That's what this statement does. And then we increment z. So we do all this to get that number. We print it out. Then we increment z. We run this loop again. Then once we get to the end of the first array, then we print ln, a square bracket. The reason we need a print ln statement is because otherwise it wouldn't move on to the next line. And I'm just using line breaks to indicate the end of each array, but if you wanted, you could print out like a curly bracket here at the beginning, and then print out like just a closed square bracket, and then you could even have no space. You could just have closed square bracket, then open square bracket, all on one line. Because if they see closed square bracket, open square bracket, they know that means end of one array, moving on to the next. But I've used line breaks. So we have closed square bracket to indicate the end of this array, and then I plus equals 1, and then this loop ends. So now we're moving on to the next array in the array list. Okay, so now I think you understand how this method works. Alright guys, thank you very much for watching. In the next video, I will be walking you through how to use all these concepts I've just shown you to modify our game so that enemies spawn in over time. I should be releasing that video pretty soon after I release this one. Thank you very much for watching. I will see you next time.